Evaluating logs can be straightforward if we can easily find the exponent on our base, or if we're doing the natural log or the common log. Natural log, remember, is base e, and the common log is base 10. Those are easy because we can always do those on the calculator. But if it was log base 2 of 50, I would have to try to find an exponent to put on 2 times itself a certain number of times, that would equal 50. Well, that's not one that we're familiar with. We can't multiply 2 times itself a whole number of times and get the answer. So we need a way to change that to something we can do on our calculator. So we're going to use this change of base formula here. It says if you have the log of any base b of m, then that's equivalent to taking the natural log of m divided by the natural log of the base b. Or if you prefer, you could use the common log of m and divide it by the common log of b. Now I am going to use something in here that we haven't studied yet, but I think it's pretty easy. If I have log base b of m is equal to y, by definition that means that this base raised to this exponent y has to equal m. So I just converted it to the exponential form. Now I know if I start with two equal things, I can take the natural log of both sides and the answer will still be equal. So that's all I did, take the natural log on both sides. Now there is a property for logarithms, any kind of logarithm, that says if you have the log of something raised to a power, that's equivalent to taking that exponent and putting it out front and multiplying it with the natural log. And then we're solving for y, so I'm going to divide through by the natural log of b, and y is equal to ln of m over ln of b. And what was y again? It was log base b of m. So we just proved it. You're not going to have to do that, but I think it's nice to see a simple proof every once in a while. Okay, so let's use this change of base formula and then our calculators to evaluate log base 2 of 32. It says that I'm going to take the natural log or common log, doesn't matter which one, of the thing we're originally taking the log of, so ln of 32, divided by the natural log of whatever the base is, so over natural log of 2. And we get an answer of 5. Okay, so I've got my screenshot there. But just to illustrate that it really doesn't matter, what if I instead wanted to do it using the common log? I could do that. I would take the common log of 32 and close that up, divide by common log of 2, and guess what? The answer's still 5. We know that's correct because if log base 2 of 32 is 5, that's equivalent to saying 2 raised to the 5th is 32, and that would be correct.